You can start with the Vedic conception of the universe. And, of course, in the Vedic conception, the universe is created by a supreme being, by Krishna. But basically the description in the Vedas is that the earth is considered to be at the center of a relatively small structure, and the various planets, sun and moon and so forth, are circling around the earth, and going out to a certain distance there's a series of shells. Actually, it's described there are 7 shells covering the universe according to the Vedic picture. And in the Vedic literature, it's described that there are many universes existing within the causal ocean, and each one is surrounded by a series of shells like this. And these are practically innumerable. There are various descriptions given. For example, they're compared to bubbles of foam within the ocean. You can just imagine how many bubbles of foam there are in the ocean. Or they're compared to the mustard seeds in a barrel of mustard seeds and so on. Well, in other parts of the world, this same conception existed. So, in the ancient Mediterranean area, where the Greek and Roman civilizations and so on existed, people also had practically the same conception of the universe. As far as I'm aware, the idea of many universes floating within a causal ocean was not described outside of India, although maybe people did have that idea, but it just hasn't come down to us so prominently. But the ancient Greeks, for example, also had the idea of a universe which was contained within a shell. The Earth was at the center, and the different planets were moving around the Earth. So that conception was there. Now, in the Vedic literature, there's one basic description of the universe, which in the books we have is presented mainly in the 5th canto. And that describes a number of unique features, such as a universal mountain, which we call Mount Sumeru, and so on. You also find that in very ancient times, people in many parts of the world had this idea of Mount Meru. For example, the Greeks had this idea. They called it Mount Olympus. And by the time we come to the Greek civilization, they had placed it in Greece, a sort of parochial viewpoint. But the Greeks were fond of Greece, so they wanted everything to be there. So their Mount Olympus, though, really corresponds to Mount Meru, because it's a mountain on top of which the gods are dwelling. Zeus and so on lived on top of Olympus. So likewise, on top of Mount Meru, there are the dwelling places of different demigods and so forth. Also, the Scandinavians had the same idea. I once saw a map of the universe according to the ancient Norse, the Vikings and so forth. And there was a central island with a ring-shaped ocean around it, and in the center of that island there was a vast mountain. And on top of that mountain there was what they called Asgard, which is the dwelling place of the gods, with Thor and so on and so forth. So this conception of the universe used to be found all over the world. You can trace it in many different cultures. So that's one conception which was existing in ancient times, but also in ancient times there's existing the conception of the Earth as a globe and the planets as moving around the Earth in different orbits. So that's also there in Vedic literature. there are books such as the Surya Siddhanta, which describe the Earth as a globe, and they describe how the different planets orbit around the Earth. And these texts give mathematical details for calculating where the planets are at any given time. This is of interest to astrologers because they do their astrological calculations based on where the planets are within the zodiac. So these scriptures also provide rules for calculating when eclipses of the sun and moon take place. And you can do more sophisticated things. You can calculate when the sun and the moon will be at 90 degrees from one another and different things like this. So the relationship between the fifth canto type description of the universe and these descriptions of the Earth as a globe with the planets going around is a whole subject of discussion, which I can also get into. But just to give a short historical summary of what happened. As I was saying, in the ancient world, the Greeks had the same basic idea. Then, after the Greeks came the Romans, who didn't really do much in the way of astronomical investigation. They were mainly interested in politics. And then, of course, the Roman Empire collapsed, and in the Middle Ages, nobody did very much because they all became Christians. And so they weren't actually very much interested in things such as astronomy. But then came the Renaissance, which is very famous, when in Italy and also other parts of Europe, people began to rediscover the writings of the ancient Greeks. Those had been lost in Europe during the Middle Ages, but the Arabs kept them intact, more or less. Not really intact, because probably one book out of 1,000 or something like that has come down from the ancient Greeks. Yeah?
You mean Arabs like the Moors in Spain, or actually Arabia, or the Persians? Or?
Yes, the whole group, because starting with the Mohammedan conquest, the Arabian civilization extended all the way from the Sind province of India in the east to southern Spain. In fact, they actually went up as far as southern France for a while. So there were different groups, such as Moors and so forth, but they were all basically, for example, their basic language was Arabic, and of course they were all Muslims. So they had a unified culture over that vast area for quite a long time. And they kept alive the Greek culture. There are various Arabs who learned Greek and who read Plato and so on at a time when in Europe nobody was doing this. So, in the beginning of the Renaissance period, Copernicus revived the idea that the sun is the center of the universe and the planets are orbiting around the sun. There was a Greek named Aristarchus of Samos who had speculated about that in the period of Greek civilization. So initially, all Copernicus did was shift the location of the sun, but everything else remained the same. The universe was still covered with a shell, and everything was still very close. But then people began to consider that, well, if the planets are moving around the sun, then the fixed stars must be very far away, or else we'd see parallax. Now, when surveyors measure the distance, say, of a distant object, like the peak of a mountain, what they do is they stand in one place and measure the angle to that mountain, say, from north. And then they move over to another place and measure the angle from north. And they know the distance that they moved. So now they have one side of a triangle and two angles, so they can determine the other side. And that gives them the distance. That's called triangulation. So the change in angle when you move is called parallax. So if the Earth is on this side of the sun at one time and half a year later it's on the other side, then it's moved by quite a large distance. So if a star is over here, you should be able to measure how far away it is by measuring parallax. The same method. But when they made measurements like this, they'd see no change in the angle whatsoever. So this was taken to mean that the stars were very far away. Now another explanation might be that the Earth isn't moving. That's why you don't see a change. But once it's established that the Earth is going around the Sun, and it's covering such a large distance in half a year, then if you don't measure any change in angle to the stars, that means they must be so far away that you can't measure that change. So the idea became that, well, the stars must be very, very, very far away. You can calculate how far they'd have to be. It's an incredible distance. It's measured, in fact, in what they call parsecs, which is a word you'll find in the science fiction stories. A parsec, in fact, is the distance at which something would have to be so that the angular change in half a year that you would measure would be 1 second of arc. So that's several light years, in fact. So the universe became very large, and this immediately created problems because in the old system of thought, people would of course ask, well, what's beyond the shells of the universe? Well, the answer would be heaven. By heaven, they mean what we really mean by Vaikuntha. Because also in the Middle Ages and in the ancient times, it was of course believed that there was a celestial realm, what we call the heavenly planets, or Svarga Loka. The Greeks also believed in such a thing, and of course they had their demigods such as Zeus and so on. Aristotle, for example, taught that there's one kind of matter that exists on the earth, which is gross corruptible matter. It has the characteristic of decay and so forth. But once you get beyond the moon, the matter that makes up the universe is of a different character. It's what you could call celestial matter. And it doesn't have the property of decay. Everything beyond the level of the moon is perfect and eternally existing. Of course, the Greeks thought that their demigods were actually eternal, whereas in the Vedic literature we understand that they live for vast periods of time, but they're not actually eternal. They also die. But of course, in the ancient Mediterranean world, the lifespan of a Vedic demigod was so long that it would practically be eternity, because they thought in terms of thousands of years for the existence of the entire world. For example, in the Bible you hear about creation in 4004 BC. Well, back in those days that wasn't at all an unusual idea. So when the Vedic literature speak of a Manu period lasting 306 million years, or a day of Brahma lasting 4,320,000,000 years, that's practically eternity from the viewpoint of ancient Mediterranean people. So the idea then was that there was a heavenly realm. The Christians populated the different planets with angels, which are practically like demigods. If you read Dante, with his Dante's Inferno and Paradiso and so forth, you'll read that in the moon, the moon is the place where pious people who really weren't all that great spiritually, but still were pious, would go after death. So they would live in the moon. And then people who were a bit better would go to other planets, such as Venus and so forth. And then those who were really very advanced spiritually would be able to go to the Empyrean realm, which is actual heaven, which lies beyond the shell of the universe. So the idea is that people were thinking that there's this shell to the universe, and as you go out beyond the earth, you come to celestial regions of demigods, then you come to the shell, then beyond the shell is the kingdom of God. And God is there, presiding over his spiritual kingdom. So they had a place for God. It was all very believable and understandable. So after Copernicus, though, when the stars were made so far away, the shell was done away with. And the universe became a vast region of mostly empty space. Because if the stars go so far away, then mostly you simply have empty space. And so it hardly seems plausible that that could be inhabited by demigods, because it's just a huge void, basically. So, and then also, where does the kingdom of God disappear to? Because if there's no shell anymore, then there's no more room for a kingdom of God. And another thing that developed in the Renaissance was that people started applying geometry to understand nature. This wasn't done in the Middle Ages, and even the Greeks didn't really do it. The Greeks were the people who developed geometry to a large extent. This is what you'll be told if you go to school. But it's not necessarily true, by the way. For example, in the Vedic literature, there's something called Silpa Shastra, which is a practical manual for how to construct fire sacrifice altars. And it contains elaborate geometrical rules. It seems that in the Vedic period, an altar had to be constructed with very great precision. This is similar to the fact that the mantras used in the sacrifice had to be pronounced in a very precise way, or else they would not have the proper effect. So similarly, the altar had to have just exactly the right geometrical form. And so they used geometry in order to construct these forms. So they had all kinds of geometrical rules whereby you could construct different triangles and circles and so on in an appropriate way. For example, the altar might have a very elaborate shape, like the shape of a large bird. But the area had to be precisely fixed. So how do you build a bird-shaped structure with the right angles and so on, which has a given area? And then for a more elaborate sacrifice, you may have to multiply the area by 2. So if you multiply the area by 2, how do you change your construction so that it has the right shape, but now twice the area? So they could solve all those problems, and they used geometry to do it. For example, the Silpa Shastra uses the Pythagorean theorem, which says that if you have a right triangle, the sum of the squares on the sides equals the square on the hypotenuse. And they had it in general form also, not just in specific cases. So, the interesting thing is that in the Silpa Shastra, though, no formal discussion of geometry is given. It just uses geometry. So somewhere else there must have been a discussion of all the basis of geometry, but that literature no longer exists. At least nobody seems to have it, because many things also have been lost in India. So, over the course of years with different invasions and so forth. So the Greeks had developed geometry, and everyone has heard of Euclid. Euclid wrote a systematic treatise on geometry, and that became the standard for the study of geometry. So, in the old days, though, even in the days of the Greeks, the tendency was to use geometry as a practical tool. Just as in the Silpa Shastra it was used for practical purposes of building altars. However, the Pythagoreans had a different idea. They were thinking that somehow geometry is the basis of reality. And geometry can be based on numbers. So ultimately, numbers are the basis of everything that's real and that exists. So, in the Renaissance, this idea was revived. But the people in Europe in the Renaissance really took this up wholeheartedly, whereas previously that hadn't really been done. Because previously people were thinking that the ultimate basis of reality is something spiritual. And there's no way that you can discuss something spiritual using geometry. How can you explain God in terms of triangles and circles and so forth? So, and people were thinking that there's a reality to mind. Mind really exists. In fact, mind is more important than matter. This is how people used to think. So, but you can't understand mind in terms of mathematics. That, in fact, has been the history of modern science. No one has been able to understand mind in terms of mathematics. So in modern science, the tendency is to say, well, there's no such thing as mind. It doesn't exist. So this idea of explaining everything in terms of mathematics became established. So then Euclidean geometry became the model for the universe. So in Euclidean geometry, there's space that goes to infinity. There's no limit to it. It's simply infinite. And you can imagine little stars scattered throughout space, going out to infinity. So this became the picture which developed. So this leaves no room at all for God as a personal being ruling a kingdom somewhere. Because where are you going to put God? If reality consists just of Euclidean space going out to infinity with no limit, then there's no place for God. But of course, people already had many impersonal conceptions of God. So you can imagine God as some kind of all-pervading spirit which cannot be visualized as having any kind of personal form. And you can say that the naive, common people may think that God is an old man with a beard sitting on a throne somewhere, but we know that actually God is an indescribable spirit. And also, some philosophers began to develop the idea that God really is geometry. And in fact, Isaac Newton took up that idea. Because Isaac Newton believed in God. He had to, because in those days, if you didn't, you were in real trouble. They'd burn you at the stake. But Newton had the idea that, well, space is the sense organ of God, just as we have our senses like eyes, ears, and so forth. So Newton thought that Euclidean geometrical three-dimensional space is God's sense organ. So naturally God is all-pervading and he sees everything because space is everywhere. So he essentially identified God as space. The idea was that then space is conscious and it can see and feel and so forth. And so therefore, and God is space, so therefore God knows everything. That was Newton's idea. So you see, by the way, what it means when it said that Newton believed in God. One has to be a little bit careful. It's not that he believed in Krishna or had any such conception. So the idea then was that the universe is Euclidean space and stars are scattered throughout space going out to infinity. Then there came Olber's paradox. And Olber's paradox, and by the way, in this picture, the solar system with the Earth and so on is totally insignificant. It's just like a speck in a vast void. So this led to a very materialistic picture of things. Then came Newton, who gave mathematical formulas saying how the planets move. And this eliminated the need for an intelligent being to be controlling the planets, because it should also be pointed out that in the Middle Ages, the people were thinking that the planets were guided by there's an angel behind each planet, or sort of within the planet, and that angel was moving the planet. Well, of course, that corresponds exactly to the Vedic idea, because according to the Vedic conception, there are planetary demigods. That is, the graha, or planet, in the Vedic conception, is really the demigod. For example, in the description of the churning of the Milk Ocean, we find the sun and the moon sitting down together to drink this nectar. And then Rahu sits down next to them because he wants to drink it too. And so on. So the planets were regarded actually as personalities. And also there's a personality of the Earth, namely Bhumi. So that idea was also there in ancient times in Europe, and even Kepler still believed that. But after Newton, that whole idea was regarded as, of course, being totally outmoded and ridiculous, a product of past superstition. So there were no more angels moving the planets. So the solar system became a tiny little mechanical clockwork in which planets were spinning around the sun, but this was just a speck in an infinite void, populated by other similar specks, in which you might also have planets circling around other stars and so forth. And by the way, when the stars were moved so far away, that's when they became suns. This is a distinction between the Vedic and the modern Western picture of things. In the Vedic literature, it is not said that the stars are like individual suns. They're more like planets reflecting light. But if the stars are so far away, as the people were now believing, then they have to be very bright so that they can be bright enough for us to see them. That means they have to be suns. And if they're also suns, then they can have planets and so on, and the whole realm of science fiction then is opened up. So, but then some people came up with what is called Olber's paradox. And that is that if you have stars scattered through space going out to infinity, you take a shell of radius r, the surface goes up as 4 pi r squared. The intensity of light from one star goes down inversely with the square of the distance. The number of stars on the shell should be proportional to its area. That means each shell should contribute about the same amount of light on the average. If there are infinitely many shells going out, that means we should be getting an infinite amount of light. That means it shouldn't be dark at night. Rather, there should be infinitely intense light striking us at all times, which means that there would be infinite temperature and we couldn't even exist. So what that meant was this picture of the universe extending out to infinity in this way was impossible. Such a thing could not be, at least according to their idea of how light operates. And that includes the inverse square law and so on. So this began to sink into people's minds, and various attempts were made to get around it, and nobody could do it. So finally, people began experimenting again with the idea of a finite universe. And so Einstein came up with the idea of curved space. He threw out Euclidean geometry, and he introduced non-Euclidean geometry. And the basic idea of non-Euclidean geometry is that space itself curves. To make an analogy to this, in 2 dimensions, the surface of the Earth is a globe, and that curves in on itself, so that the total surface of the Earth is finite, even though there's no edge anywhere. So you can have a finite surface, but it doesn't have an edge if it curves in on itself in the form of a sphere. So some mathematicians thought, well, you can do this with 2 dimensions if you curve it within 3 dimensions, as with the surface of a sphere. And then they said, well, we don't even need the 3rd dimension, because mathematically we can describe the surface in terms of the local relation between the points on the surface, and we don't even need the 3rd dimension that we embed it in. That's just useful for imagining how it curves in on itself. So they said, well, we could do the same thing in 3 dimensions, or n dimensions in general. So you could imagine space like 3-dimensional space that curves in on itself, so that there's no boundary anywhere, but there's a total finite volume. So mathematicians just toyed with this, just as part of their own fun and games. A fellow named Riemann developed it in detail. So Einstein used this to provide a model of the universe which now was finite instead of being infinite. But there were no edges, so there's no shell to the universe. So he proposed that model. But he thought of the universe as being fixed and static, which was also an ancient idea, that nothing is really changing out there. Things remain the same for very, very long periods of time. So a fellow named Friedman discovered that according to Einstein, the universe really should be expanding. It's because his model was unstable. It wouldn't just stay fixed. It would expand like that very rapidly. And meanwhile, Hubble, who was observing galaxies with the Mount Palomar telescope, came up with the argument that, well, it seems that the galaxies are moving away from us. And there's a whole explanation as to why they think that. So he said, well, the universe is expanding. everything is moving away. It's as though we're situated in an explosion in which all the little particles in the explosion are moving away from one another very rapidly. So, at a certain point, Hubble got together with these people who said that Einstein's universe should be expanding. Because if the universe is expanding, then what happens if you look backwards in time? Well, it must be contracting. So you go back in time and it gets smaller and smaller and smaller until it goes down to a point. So that means that at some time in the past, there must have been an explosion starting with a point. So this was the idea of the Big Bang. And so then people began reasoning about, well, what things must have been like if this was true. For example, if you go back and everything's crunching together into a point, then it must be very dense because all the matter has to be scrunched together in one small place. And it's observed that if you take something and compress it, it gets warmer. For example, if you take gas in a cylinder and compress it, the temperature goes up. So if all the matter in the universe was compressed into one small region sometime in the past, then it must have been very hot. So in fact, it must have had a temperature of millions and millions of degrees, you can calculate. So that means this explosion involved intense heat, and everything was in the form of just particles bouncing against one another. Even atoms could not hold together under this intense heat. So people speculated like that. Yeah?
Just want to interject quickly. Is this perhaps where they developed the idea of the atomic bomb simultaneously?
Well,
not too far off the track.
The idea of the atomic bomb developed at about the same time. That was another development, however. But that happened because they were studying atoms and subatomic particles and so forth.
That wasn't connected with the small, very intense, that when it expands gives off a lot of heat.
Well, of course, an atomic bomb is an explosion. But there the idea is that you're releasing energy which is already stored up in the matter. And when the energy is released, the thing explodes. But the Big Bang was a different kind of explosion, because in Einstein's theory, you see, another thing about the situation is that as you go back, the contraction going backwards in time proceeds right down to a point. Mathematically, this is what happens in Einstein's scheme. It's not that you go down to something very small, and that's the starting situation. But actually, you go right down to a point. Which means now going forwards in time, you start with a point, and the universe has to come out of a point. Now, this immediately is a problem with this whole theory, because starting with a point, why do you ever have anything but a point? Why should a point create a universe? After all, supposedly there are lots of points around. Here's a point. Here's another one. So why doesn't that generate a universe? So no one can explain why a point should generate a universe. So in the early days of the Big Bang theory, the customary response was to say, well, now we have gone beyond the realm of science and entered the realm of metaphysics. Or scientists would just say, well, I won't speculate about that. That's a common answer. Which is a little ironic, because they've been speculating like anything to come up with this whole theory. And then when there's a problem with it, they say, I do not indulge in speculation about such topics. So back in the 30s or thereabouts, that was the standard answer that they would give. So, and also in those days there was a competing theory known as the steady state theory. This is an amusing theory. According to this one, the universe is infinite and expanding. Well, if it's infinite and expanding, everything's moving away from everything else. But according to this, matter appears out of nowhere in the intervening space. And this just happens. Because if you can postulate one thing, you can postulate another. So why not postulate matter coming out of nothing? May as well. So After all, if you're going to postulate the universe coming out of a point, why is it bad to postulate a little bit of matter coming out of a void? So according to this theory, the universe is expanding and matter is popping out of the void and providing new galaxies to fill up the space. And it all balances out so that the thing is in a steady state. As the galaxies get further apart, new galaxies appear, so you always have the same number of galaxies in any volume. So that was the model invented by Fred Hoyle and his collaborators. But that model got kicked out, and Fred Hoyle became a renegade, and now, Fred Hoyle has hidden out in the mountains of Wales somewhere, and his address is not even available. But then that's because of other infractions that he committed in the scientific realm. So practically they tarred and feathered him and drove him out. In England, traditionally, whenever anybody became a renegade, he'd hide out in the mountains of Wales somewhere. People used to do that to avoid being burnt at the stake, in fact. But so Fred Hoyle's hiding out. Of course, he committed other crimes. Fred Hoyle finally became a creationist. He argued that God created everything. And for a scientist to do that is the ultimate heresy. And then even worse, he did things like argue that interstellar space is full of things like bacteria, which was considered to be a very bizarre thing for a scientist to propose. And then he even went so far as to give evidence for it, which was almost worse. So if you mention the name of Fred Hoyle to a scientist these days, he'll immediately start cursing, because everybody's learned the word on Hoyle. So the steady state theory is out. So the Big Bang theory was considered to be somewhat speculative, though, up until a few years ago. And a few years back, it seems that some scientists named Penzias and Wilson, who worked for Bell Labs, were directing a radio telescope to various directions in the sky, and they picked up this dim hissing sound, meaning that radiation was coming in at a certain wavelength. And they couldn't figure out what the source of it was, because it was of the same intensity in every direction. So it didn't seem to come from any obvious stars or planets or galaxies or anything like that. And originally they thought their equipment may be just producing the hiss, but they checked all the equipment and nothing seemed to be wrong. So then some other people said, well, if the universe began with a Big Bang and there was intense heat in the beginning, then there was intense radiation propagating in all directions. So as the universe expanded, this radiation gradually became dimmer and dimmer. It's just like when an explosion goes off. First you see this burst of light, and then it fades out. So the idea was there must have been this radiation that over all these years since the original explosion has been fading out. But still it should be there with a certain intensity. And so they calculated that it would have a very, very low intensity. And it should be the same in all directions, because the explosion is completely uniform according to this theory. So these people said, aha, the hiss that Penzias and Wilson are picking up in all directions must be that original primordial radiation from the Big Bang. And they said, aha, that proves it. That conclusively demonstrates that the universe did come about by a Big Bang. Well, that was their reasoning. So that may seem a little tenuous. But what happened then was what you could call the Big Bang bandwagon got started up. And it became established that you have to believe now in the Big Bang. Because how else could we explain that radiation? So the steady state theory was completely repudiated, and the Big Bang theory was established. And since then, it has become the established dogma. Now, this is a phenomenon that tends to happen in science. In science, what will happen is that a given theory may be rejected for years, and it doesn't matter what evidence is in favor of that theory. It's just rejected. But then at a certain point, a sudden flip-flop will occur, and the theory will be established as truth. Everyone will accept it. And the evidence that used to be rejected as being totally inconsequential is now accepted as proof that the theory is true. So that happened with the Big Bang Theory, because the Big Bang Theory really got started back in the 30s or thereabouts. And in the late 40s, George Gamow predicted that all the different elements in the periodic table could have been synthesized in the Big Bang. But then later on, people realized that mathematically that wouldn't work out anyway. So you had to have some other explanation for where the elements came from. So up until the 60s, the Big Bang wasn't accepted. But then when this discovery of the so-called cosmic black body radiation was made, that did it. And everyone flipped over and began accepting the Big Bang. So now it's accepted practically as the gospel truth. And if you talk to scientists, you'll find that they take it for granted. They just regard that as, accepted. It's not even open to question. So, of course, in science, you'll also be told by scientists that in science we never prove anything. We always merely consider tentative hypotheses. This is supposedly what scientists do. That's the creed. But at the same time, you'll find, so therefore a scientist really shouldn't believe something like the Big Bang Theory. He should just consider, we don't really know, but this is a tentative hypothesis. But what you find is that people, being people, have to believe something. It's actually human nature to believe something about the world. And so, the scientists are no exception to this. So they also have to believe something about what's really there in the world. So nowadays, the tendency is to believe the Big Bang Theory. There are a few scientists who don't accept it, but they're considered to be eccentrics nowadays, and there are just a few of them, a handful, essentially. So everyone else is riding on the Big Bang bandwagon. So that's a historical account of how this all came about. Now you can see essentially from that what our task is, or what we're trying to do essentially, because we're trying to take this whole process and go all the way back to the original Vedic conception of the universe, which I started the description with. So essentially, that's like reversing the whole course of history as it's taken place over the last 300 years or more. We want to go, it's like saying we're going back to the Middle Ages. So people will tend to think that that is the most ignorant and backwards and completely useless thing you could possibly want to do. It means throwing out all scientific progress and going back to the age of superstition when people still thought that angels were moving the planets around. But that's what we're saying. So you can see the task which we're confronting. And of course we actually have to confront it. Basically our tendency is to really not discuss these things. But there's no way around it if we want to solidly establish Krishna consciousness. And Srila Prabhupada was of course very well aware of this. And that's why he wanted the Bhaktivedanta Institute to carry out this program. And I should mention here that, as you know, Srila Prabhupada wanted to create a transcendental city in Mayapur. And in the center of this transcendental city, which will be one of the wonders of the world, and will attract the attention of people all over the world. In the center of this city, there's supposed to be a huge temple called the Temple of Understanding. So the idea is that this temple will be the center of all spiritual, metaphysical, and physical understanding of the nature of reality. And all the different creeds and conflicting views that people have can be reconciled by the Vedic understanding, which will be presented in this Mayapur center. And in the middle of that temple, Srila Prabhupada wanted a model of the universe according to the Vedic description. That means that this model of the universe will be the very center of attention for the entire world. That means that Srila Prabhupada was putting a model of the universe according to the 5th canto at the center of the preaching effort of the Krishna consciousness movement. So one should consider what the implications of that are. That means we can't avoid it if we want to carry out that instruction. There's no way we can just go on and preach and think that, well, we'll just leave this aside because only a few questions come up now and then, and, well, we won't put much emphasis on it. At least we can't do that if we carry out this instruction. Well, it's getting late again. We'll have further additions to this class. Any questions or comments? Yeah?
In this Big Bang Theory, is there a conception that originally there was no space existing?
Yeah, that's an important point. In Einstein's conception, space curves in on itself. So what is outside of the curve? Well, nothing. It's not even imaginable. All of space is just this closed, curved continuum. And there's no outside. You can't even get outside, because wherever you go, you just go around the curved continuum. There's no way out, and there's no outside. So all of space is this closed continuum. And as you go back and back, it gets smaller and smaller. And when you go right back to the initial point, there's no more space. That means nothing exists. It's not that there's a void, and a point in the void explodes and fills up the void with the universe. That's not the conception. The conception is that there's nothing. Literally nothing. Not even space. So that's the conception in the Big Bang Theory. Yeah?
No, you mentioned it being the concept of a closed shell of the universe and how it was going to develop the parallax to measure the distance of the stars. But when you said it, when the Earth was on one side of the sun, half a year later on the other side of the sun, you couldn't find any discernible difference between the angles that we can start.
Yeah.
So wouldn't it also be possible that not just that the Earth is moving, but also that star is moving in such a way that there wouldn't be any discernible difference?
Yeah, but you can see what that means. That means as the Earth is going around like this, in its orbit, all the stars have to be going along like that too. That's a pretty implausible picture of things. Why would they be doing that? Moving just in the same way that the Earth moves. So no one ever seriously proposed that as an explanation. Of course, there's another way of looking at that, by the way. If, as the Earth goes around in a circle, all the stars are going around in a circle too, that means, in effect, all of reality is going around in the same circle, so why not just say that that's standing still, including the Earth, and the sun is going around the Earth instead? If you see what I mean. Because you're saying the sun is standing still, and so to speak, the whole universe is executing a circular movement like this.
That their instruments weren't fine enough to discern it.
But you see, that may be that they had crude instruments. But even if you can only measure angles crudely, it still means that the stars have to be very, very far away. For example, the moon occupies 1/2 degree of arc in the sky. And we know how large the moon looks when it first comes up over the horizon. This was observed last night. So that's 1/2 degree. So you can measure distant angular differences of less than half a degree, even using a crude instrument made out of wooden beams and so forth. For example, Tycho Brahe, the Danish astronomer, built very large devices in which a wooden beam moves on a hinge, and you sight along a line at a star using the eye. And then you have a calibrated arrangement like a protractor in which you measure the angles. So he used this method of measuring angles to things. Well, you can come within a fraction of a degree with that easily enough. So if there's no movement of that size, still the stars have to be very far away, because the distance traveled by the Earth in half a year is twice the distance to the sun, and that's a very large distance. So it means the stars have to be many, many times that distance in order for the triangle with that as the base to have such a fine point. Yeah?
I was wondering, since you were talking about the one scientist who came up with the far out story and he running away, what kind of report did you still have a lot of contact with scientists? What's happening with the report with these scientists? What kind of influence you have with them, or what they think about it, or if they know they have to know what you're doing?
Well, I have contact with various scientists. Basically, what I'm trying to present to them, though, is simply the more fundamental point that life is not material. And that consciousness is a non-physical reality which can influence what matter is doing, and also provide for the idea of the supersoul. That is, two kinds of consciousness: individual consciousness and the supreme consciousness. So this is, these are very basic points. I haven't tried to discuss cosmology with the scientists yet. We have, in order to do that successfully, we have to establish a much more solid foundation than we have right now. We have certain basic points that we can make, but essentially, you see, in this magazine, all we do is criticize the basic Big Bang model. Now notice what we're doing. They say the Big Bang occurred billions of years ago, about 20 billion to be exact, or 16 billion. They change it all the time. And they're talking, and it involves observing things at very large distances, going out to, well, they'll say 10 billion light years for quasars and things like that. So we're criticizing them at that level of speculation and saying, well, really, this is pretty much baseless. Just see how they're speculating in various ways and look at the different contradictions here. What need is there really to accept this? That's one basic point we make there, because Srila Prabhupada wanted us to refute their speculative arguments and show that it's all just speculation. So we're starting with the most speculative things that they're saying. Now, another thing you might discuss is the argument that the stars are really so far away. But that's coming much closer to home. And another thing you might discuss is the heliocentric theory itself, how the sun and the moon are operating and so on. And then going even further, you can come to the point of discussing Mount Meru and questions like that. So with each step you take in that direction, what you're saying becomes more and more unbelievable to a person with scientific background. So we have to establish a more and more solid presentation. Actually, many things can be done to establish this. It's not that it's a hopeless thing. Now, we took one step in that direction in this article, although it's not pointed out explicitly why we took this step. Nonetheless, in setting up this magazine, we're planning for the future. So we discussed such things as the fact that in the quantum theory, one interpretation of quantum mechanics is that there are multiple parallel universes that are invisible to us. That's what this diagram shows here. The runner splits into multiple runners in multiple universes, and they all have different histories. Some scientists are seriously proposing such a thing in the quantum theory. So we're pointing out that they're seriously talking about the idea that there can be whole realities with people and so on and so forth that are coexisting with us and we can't see them. And they also make that point in a different way with their idea of missing mass. We illustrate here the concept that the galaxies that we see represent only a fraction of the mass of the universe, and there's a vast realm of mass, maybe 99% of it, which we can't see or detect in any way. There are reasons why they propose such a thing. So lately, they've been talking about that at great length. So that's another indication of how they're thinking that it's possible that there can be invisible worlds, which we can't pick up with our senses. They're even speculating that in this invisible matter, the matter could also be organized in the form of planets and living beings and so on. What is the point here? What we want to argue is the basic point is the scientists themselves are considering the possibility that there could be invisible realms in which things are going on that we can't see. Well, in the Vedic literature, that is the very thing that is described in great detail. We certainly can't see Mount Meru. We can't see the ocean of milk. We don't even know where you would look. Say you go to Mount Palomar and you have an opportunity to use their telescope there for a few hours. Let's say you want to see Mount Meru. Which way do you point the telescope? Do you have any hope of seeing it that way? It's absolutely out of the question. So, actually, this Mount Meru is supersensual, you could say. We can't pick it up with the senses we have. So, someone may say, well, this is certainly bizarre superstition. How can you believe in all these things that you can't see? Isn't this absurd? But we wanted to make the point here that the scientists themselves are proposing such things. Of course, they're doing it in their own speculative way, but they're also proposing such things. So if the Vedic literature proposes such things, then what's wrong with that? In fact, another point can be made that if, in fact, there are realms of existence that you can't pick up with your senses, then you can't really hope to use the empirical method to understand these realms of existence, simply because you can't pick them up with your senses. But using the descending process, which is the basis of Krishna conscious philosophy, you can hope to find out about such things. At least in principle, you can see that it's possible to do that by the descending process. So this idea of invisible realms of existence fits in with our basic picture of things, and not with the scientist's picture. So that's one basic point we wanted to make here. And I should point out another thing that can be done with the, as far as this whole subject is concerned, is examining various empirical things that don't fit their theories. And there are many things like that that actually are observed.
Thus far, I've been making some comments about the first article on cosmology or the Big Bang. So essentially there are four main themes to this article, namely, first of all, that the scientists' theories are highly speculative. Secondly, that there are definite defects in these theories that can be pointed out. And then the third one is that the Big Bang model, as is true of all scientific models of origins, cannot explain how variegated, complex reality emerges from something that was not variegated and complex. That is, how can something come out of nothing? And then the fourth main point here is that the picture of reality presented in the Vedic scriptures is essentially what we call higher dimensional, to use a term borrowed from science. But the scientists themselves are proposing various things that are higher dimensional. So if the Vedic literature proposes it, what is wrong with that? So those are four basic points that are made in this article. And of course, two of those are negative in character, namely that the theories of the scientist are speculative and that they have various defects. So that merely, those points are merely made to tear down what they're saying. But the other 2 points also can be used to build up the Vedic worldview that we would like to present. So I've thus far made some points concerning this idea that reality is actually higher dimensional. So I think I should make a few more points about that because this is quite important. So the last time I gave a historical summary in which the basic point was that originally people believed in a universe in which there was room for a personal God. Outside of the shells of the universe, there's what in Europe is called the Empyrean realm, which we would call Vaikuntha. And this is where God as a person can have his kingdom. So this made it very easy to believe in God. After all, what are you going to put outside of the shells of the universe anyway? Simply a void. You have to have something there. So what happened, though, with the development of modern cosmology and astronomy is that the idea of the universe with a covering and then a region outside in which God could exist was replaced with the idea that reality is three-dimensional Euclidean space that extends to infinity and is just full of matter. And the matter, for that matter, is very thinly distributed. It's mostly just empty space. Well, by the way, we have this cartoon here. It seems this is a thing that we contrived. Actually, this is a picture of, this was originally from Martin Luther's Bible, no less. And it was a picture of Jehovah presiding over the creation. So in this circle here, originally there was a picture of the earth with Adam and Eve standing in the Garden of Eden. And significantly enough, it shows the universe contained within a shell. So Martin Luther was thinking that way. It's an interesting point. But what we did was put the Big Bang here in place of the Garden of Eden. And then in the original picture, Jehovah was holding his hands up in some kind of Western mudras, indicating his benedictions. But we put here a clipboard with an equation in one hand and a calculator in the other hand to indicate the modern conception of the creation, namely that everything is running according to some equations. So actually the point behind that is that according to the modern scientific theories, the whole world is running according to the solutions to some mathematical equations. And if God exists at all, his only role is to sustain matter so that it can interact according to those equations. In fact, we were just looking at this BBC broadcast in which a physicist from Cambridge followed a semi-Vedic practice by becoming a Roman Catholic priest when he became old. So it's almost like taking sannyas. So this was considered to be quite unusual. But he was expounding his philosophy, which is that God is simply sustaining the universe, holding everything up, as it were, and that everything is happening within the universe in accordance with the laws of physics, which are set up by God. However, if that's true, it eliminates religion completely, because it means that we are simply arrangements of atomic particles, or whatever they may be, moving according to the laws of physics. And it may be that God is holding the whole thing up so it can all happen, but still we're just moving according to the laws of physics. So if we pray to God, that's just another thing that's happening according to the laws of physics. And it has nothing to do with God. And there's no question of God responding to our prayer, because if he did that, he'd be interfering with those laws. But that's not what he's doing. He's just maintaining the laws. So, in one stroke, this philosophy totally kicks out religion. You may have God, but you don't have religion. And you don't have the idea that the individual human being has anything to do with God. The human being is just a collection of atoms. So, this is the philosophy of deism. So actually the Vedic philosophy gives a quite different viewpoint. There are laws governing how matter operates, and Krishna is enforcing those laws, but they are more like the laws of a state or a nation in which there are options for doing different things. They're not like the laws of physics in which everything just flows from cause to effect inexorably. So, and also Krishna can either enforce his particular laws, which basically these are known as the laws of karma, or if he wants, he can not enforce them. In fact, that's Krishna's role. We were saying the other day, Mukunda means that Krishna can give liberation. So that means that he can suspend his laws for a given spirit soul. And only he can do it. The demigods aren't granted this power because they're within or under the jurisdiction of the law of karma themselves. But Krishna can either enforce the laws or not enforce them as he wishes. So it's a different conception. So I wanted to say something about this idea of space. We were saying the other day that the idea developed that the universe consists of three-dimensional Euclidean space. Then Einstein came along and suggested that it consists of four-dimensional non-Euclidean space. So he introduced the idea that space itself curves in such a way that it can curve around on itself. And this is a little bit hard to imagine. The Vedic conception, though, presents an even more amazing idea about space. So, to get an idea of that, you could consider the statement made in the Brahma Samhita. Actually, it's the 35th verse, where it says that that Govinda is an undifferentiated entity, and there's no distinction between him and his potency. And it goes on to say that all of the universes are contained within the form of Govinda, but at the same time, Govinda is present in his fullness within every atom within the universe. So one can consider the implications of that. What is being said there is that within the personal form of Krishna, and of course this is very much describing a personal form here, you have all the universes. So there's Krishna, and there's all the universes there within him. So then you go into one of these universes, and then within that universe you pick out an atom, any atom you like. And you go down within that atom, so you have to tremendously reduce your scale of size to get down to an atom. And then within that atom, there's Krishna. And it explicitly says that in his fullness he's present there. It's not that just part of him is present, or some aspect of Krishna, or some manifestation of him, or something like that. But in his fullness he's present there, which means he's all there. But that means that within him there are all the universes again. And you can go down to within one of those universes, any one you like, and pick an atom, and then within that atom there's Krishna. So essentially what this is saying is that every point is connected to every other point through Krishna, if you think about that. Because suppose you could pass through Krishna. Now, this isn't even a speculative idea, because I'll give you a Shastric reference for it in a moment. But suppose you could pass through Krishna, then you could travel to any universe instantaneously. How could you do that? Well, take an atom like this one right here, and just shrink down, assuming you can shrink yourself. This power is required. And pass through Krishna and go to any one of the universes, since they're all within Krishna. And there you are. You've traveled to another universe. Just like that. So actually, if you look in the Srimad Bhagavatam, you'll find many references which show that this kind of process actually works. For example, there are 2 occasions in which Mother Yasoda looks into Krishna's mouth and sees the entire universe. In fact, it's described there that, for example, when Krishna was accused of eating dirt by his cowherd boyfriends, he said, "No, I'm not eating dirt. Just look in my mouth and see if there's any dirt there or not." So Mother Yasoda looked into Krishna's mouth, and instead of seeing dirt, she saw all the universes. And in fact, she saw Mother Yasoda looking into Krishna's mouth. So, of course you may say, well, this is just a vision. Krishna projected a vision so that Mother Yasoda experienced this. But then there's also the description of the experience of Markandeya Rishi, for example. It seems that Markandeya Rishi had asked Nara Narayan for the benediction of being able to see the material energy. This is a somewhat dangerous benediction to ask for. So Krishna showed him. So what happened was that Markandeya Rishi was given a direct experience of being able to live through the devastation at the end of the day of Brahma. So, without dying. So Markandeya Rishi was awash in the midst of the ocean of devastation. And he was simply being hurtled back and forth by tremendous waves and so forth, and there was no land anywhere. And this was a little bit disconcerting. So at a certain point, he saw this island, which was very effulgent, and which was situated in the midst of this vast ocean. And on the leaf of a banyan tree in that island, there was this little baby resting on a leaf, which was quite remarkable. And this child was extremely attractive. As a matter of fact, it was Krishna. He was laying there. And so Markandeya Rishi, of course, he was a great devotee of the Lord, so he went to see Krishna. And at this point, the baby inhaled, and Markandeya Rishi was drawn into his body. So he entered within the body of the Lord and found himself within the universe, not in the state of devastation, but in the phase of creation in which everything was there in a nice orderly fashion with the planets and so on and so forth. And then Krishna exhaled again, and he came out of Krishna's body, and once again he was in the ocean of devastation. So this is the example. So the point here is that one cannot conceive of Krishna as being situated in three-dimensional space, or four-dimensional for that matter, because the kind of situation that we're describing here is impossible if you're within, say, three-dimensional space. If you have a form within three-dimensional space, then what is within that form is definitely smaller than what is outside of it. You can't say that what is outside also lies inside. But in the case of Krishna, that is the fact. Actually, you can look at... Let's see.
He's not walking out disagreeing.
Right. He's sort of like an avadutta. Probably he's self-realized, but he's just not letting on. He doesn't want to have the association of those on a lower level of realization. So, in any case, the mathematicians have studied the idea of space quite extensively, trying to figure out what it is. And so they came up with the idea that the basic starting point for understanding what space is the idea of how things are connected together so that they're either next to each other or they're far apart. So they call this neighborhood relations. So if you take a bunch of points, let's imagine you have points, you can put them together with different neighborhood relations and get different kinds of space. For example, if you put them together in a grid horizontally, you can get two-dimensional space. So each point, you can imagine, is connected to 4 neighboring points. It goes out in a plane. Or you can imagine taking the same points and connecting them together in a 3-dimensional grid. That is, each point is connected now to 6 neighboring points. And there are various other ways you can connect them. So the idea is that the way they're connected together determines the space. So what this verse in the Brahma Samhita is saying is that from Krishna's viewpoint, every point is connected to every other point. So everything becomes a perfect unit. So now the dimensionality of space is a measure of how things are connected together. For example, in the case where one point is connected to 4, you call it two-dimensional. Or when one point is connected to 6, you call it three-dimensional. So you can go on up in that way. So if every point is connected to every point, you could say it's infinite dimensional. So that's the kind of space that's existing in the, according to the Vedic literature. So then, why do we see three-dimensional space only? Well, if you have infinite dimensional space, if you place a limitation on certain entities within that space, then they can operate only within a limited number of dimensions. So the idea is that there are different limitations that can be imposed on the senses of the living entities. So, according to the Vedic literature, the senses include senses of perception and senses that perform work. So, with senses of perception, we become aware of things in other places. This also brings up the idea of neighborhood relations, or how things connect together in space. Because our senses tell us what's happening next to us, but they don't tell us so much about what's happening far away. That's the nature of the senses. So, and also there are the senses that perform action, such as the arms and legs and so on. So with these senses, you can go to a different place, but you can only go to neighboring places, at least immediately. That is, to get to a distant place, you have to go through all the neighboring places that are in between. So the senses are related to what space is, you can say. So different beings have senses with different capacities. Krishna has senses with unlimited capacity. And so he can perceive every point in space simultaneously. In fact, it's not that these points are at a distance from him, but he is at every point in space simultaneously. So it's said he's an undifferentiated entity. He can't be divided up into parts because he's actually everywhere at once. This is almost like the Big Bang idea that you start out with a point and everything expands from it. But actually, for Krishna, everything is in a unit, completely accessible all at once. So this is essentially inconceivable from our standpoint, but that's Krishna's situation. So this means that Krishna is not situated in, say, a three-dimensional space. Mayavadis use this misconception to advocate their impersonal conceptions. For example, when I was in Vrindavan once, one Mayavadi there, it seems there are an awful lot of Mayavadis there. Everyone I met actually was one. This was at the time of the science conference we held, in which various different Indian scientists got up to speak, and every single one, without exception, presented Mayavadi philosophy. So this person said to me that Krishna is not absolute. He is completely relative, and his so-called form is full of duality. There's nothing absolute about it, and so he cannot be God. So I'll prove it to you. So here's a picture of Krishna. All right, here's Krishna's arm, right? Well, below his arm, here's air, empty space. Then you can go down to here, and here's Krishna's leg. And down here, there's his foot. And below that, well, here's more space, or earth, or whatever. So, that's duality. His body's made of different parts, and it's situated within space. It's in one place, not in another place. It's here and not over there. So it's relative. So how can you say that's the absolute truth? This was his argument. So this is based, well, let's say, on either deliberate or inadvertent ignorance of everything that's stated in the Vedic literature. Because it's actually a misconception to think that, first of all, you have three-dimensional space, and then Krishna is a form within that space in a particular place. So the actual situation is that space is manifested from Krishna. And Krishna's space is, as I was saying, infinite dimensional. And all of it is subsumed within Krishna's form all at once. And for different living entities, this infinite dimensional space is subdivided in different ways through the limitation of their senses. So, for human beings like ourselves, we're limited to a three-dimensional continuum. So that's all we can see. However, the demigods, according to Vedic literature, are not so limited. And you can see, also this is true of the various great rishis and yogis and so on. And you can see that they can appear and disappear at will. So at least from our point of view, they're appearing and disappearing. And from their point of view, they're traveling. For example, it's described that a yogi, Srila Prabhupada said actually this still happens, a yogi in Haridwar or somewhere like that could enter the Ganges River and emerge at Allahabad to participate in the Kumbh Mela. So it's not exactly that he swims underwater holding his breath. Of course, they're very expert at holding their breath, but still that's not the method. Somehow he just enters there and emerges in the other location. So for him, the way things are connected together is different than it is for us. Also, there's the Prapti Siddhi, in which, for example, in the Nectar of Devotion, Srila Prabhupada makes the point that a yogi can reach out and touch the moon with his finger. So you might ask, well, how can that be? The moon is very far away. And by any standards, it's certainly far away. So how is it the yogi can just reach and touch it with his finger? Or a yogi can reach out from here and pick some pomegranates in Afghanistan. That was one example. And they'll be here in his hand. So this indicates for him things are connected differently. Because how does he reach all the way to Afghanistan? So the basic idea then is the demigods have a higher degree of connectivity that they can operate in. And then personalities such as Narada Muni are even more powerful than the demigods in this regard. They can travel directly to Vaikuntha, for example. For example, I was just reading about how when Dhruva Maharaj was liberated, a Vaikuntha airplane came to pick him up. This took him to Vaikuntha. So there's actually air transport, so to speak, between the earth and Vaikuntha. A flower airplane can come down and you can get on board and go to Vaikuntha. If you have a spiritual body, that is. And Srila Prabhupada pointed out that unless you have a spiritual form, then it's simply not possible to do this. Even the great sages and demigods can't do it. They can't even think of how to do it. In fact, many of them don't even know that it's possible. So this was a basic point we wanted to make. So there's this illustration here in this magazine you may have seen, which is to illustrate this idea of higher dimensional reality. Actually, the outlines in this figure here are what is known as a tesseract. That's a four-dimensional cube. You can actually make drawings of four-dimensional cubes. Essentially, if you make a drawing of a three-dimensional cube, of course it's just two-dimensional anyway, from each point, three lines will emanate. If you think of the drawing of the cube. Well, in a drawing of a four-dimensional cube, from each line, you have to have from each point, you have to have 4 lines emanating. So that's what we have here. But we put here New York City on one face of this cube, and we put a sort of heavenly scene. Perhaps, maybe it's in the heavenly planets or something, on the other face of the cube, to indicate how within the same space you can have different realms of existence. So, and of course, as I was saying, this is the Vedic conception, but the scientists themselves have played around with similar ideas. So therefore, one shouldn't regard these ideas as being completely impossible a priori. For example, I pointed out this idea that in quantum mechanics, the universe is continually splitting into copies of itself, and the copies no longer communicate with one another. So according to this idea, we're having a certain experience, but this is only one universe. There's another universe that's branching off from this one in which we have different experiences. For example, there's another universe which branched off from this one, say, 10 years ago. And in that universe, we're not here today, but we're doing something else. Or maybe we got run over by a car or something. And then another universe that branched off 50 years ago. In that one, maybe some of us don't exist. Or maybe we're quite different. And so on. So there's this theory, which some scientists seriously contemplate, according to which all these parallel universes exist, but we can't see them. Other scientists think that this is all complete nonsense, of course. But it is seriously considered. So the point there is that if they can speculate about things like that, it's not such a far-out idea.
We expect that we can understand God, but He's not going to fit into a test tube or we're not able to see Him and perceive with our limited perception. We have to play that subordinate role. Is a scientific framing of thought, is that a bona fide argument? Or how would you argue that if you were to play the devil's advocate?
Well, we of course do argue this. It's a basic point, which is also made in this magazine. That point is made that the scientist's method of understanding reality is in fact to try and manipulate it and take it apart. The paradigm for that is a child taking apart a clock to try and figure out how it works, and then putting it back together again. So if you can take something apart and put it back together again, then chances are you get a pretty good understanding of how it works. So that's the scientist's approach to things. So there are certain things that are within their grasp that they can try to take apart. You could say that these are the things that are nearby and of medium size, basically. But if things are very far away or very large, then there's no way you can take them apart. And if they're very small, it's also not possible to take them apart. So the scientists are actually limited to sort of a medium range. That's why Srila Prabhupada said all their explanations take place in the middle. They can't explain ultimate origins of things. To explain ultimate origins, you have to go down to the very small, unlimitedly small things, and also to the unlimitedly large things. And also, there's the time dimension. You have to be able to go back in time. So, as a matter of fact, the scientists try to extend their the penetration of their senses using various techniques and various kinds of instruments. So to see things that are very large, they use telescopes, and then radio telescopes, and so on. And to see the very small things, they use microscopes, and also these particle accelerators are intended to enable them to see very small things. That's what they're for. And to try to go backwards in time, they investigate the rocks in the earth, and they try to use, to interpret these as records of what went on in the past. And then they try to use dating methods to find out how long ago these things happened. So in this way they try to gaze into the past. But these methods are imperfect, and they become more imperfect the further you try to extend your grasp. So indeed, there's a fundamental limitation to science. That's a basic argument we would like to make. It may be that things work very well when you're dealing with things that are immediately within your control. For example, take chemistry. In the laboratory, you can mix together different chemicals and heat them and do different things with them and see that certain reactions take place. And that's more or less within your grasp. You can manipulate these things. And you can say with fair assurance that we see that the chemicals tend to combine in such and such a way, and it happens every time we do it. But when it comes to discussing the ultimate origin of things, one has to go to things that can't be manipulated. Now, so you can say, well, how could you understand God then in that case? Well, of course, the basic point of our philosophy is that you can't understand God by the power of your senses or the power of your mind. If you try to do it in that way, you'll never understand God. You'll simply remain on a mundane platform. But if you surrender to Krishna, then Krishna, by his mercy, can tell you about himself. That is, we don't have the power to go to God using our own power, that is. But Krishna has the power to come to us if he wants. There's no limitation on what Krishna can do. So, if we please Krishna and he decides that he wants to reveal himself to us, then he can just come to where we are and present himself in a way that we can understand. Of course, that doesn't mean that we can ever understand Krishna in his fullness, because Krishna is unlimited and we're limited. So how can the unlimited present itself completely to the limited? In that case, the limited entity would have to also become unlimited. So we can never understand Krishna in totality, but nonetheless we can understand Krishna to some extent. And Krishna, by his own power, can reveal himself to some extent to us. And so, of course, the basic principle in the Vedic literature is that if we surrender to Krishna, then he'll be pleased with us and he will reveal himself. So the basic premise of Bhakti Yoga is that Krishna actually wants to reveal himself to us. That's the natural state of affairs, and he will do it if only we're willing to cooperate with him. And cooperating with God means surrendering. For a very tiny entity, that's the only reasonable kind of cooperation you could have between a tiny entity and God. So, therefore, our proposal is that if there is Krishna, who is supremely powerful and all-knowing, and so on, then there's a possibility that one can understand ultimate reality by surrendering to Krishna and having Krishna reveal himself. This is an argument you can present to someone whose position is one of total skepticism, let's say. Let's say, he doesn't believe any of these things, he doesn't accept Shastra or anything like that. But you can say that as a matter of logic, if there is a supreme being who is endowed with all these powers and so on, then it's possible that you can understand that supreme being by surrendering to him, in which case he will reveal himself. That's a logical possibility. And the only way to really know if that works, of course, is to try it. How else could you know? If you say, I won't try it, but prove to me that it's so, then what possible sort of proof could there be? But you can try it. So that's a logical possibility. On the other hand, if there is no supreme being who's in control of everything, and nothing exists but matter that extends onwards and onwards out to some vast distance, then how can we really hope to understand everything? The scientists can use their methods, but how can they ever be sure? Because, after all, one important point is that what science can do is limited to what one scientist can do, in the following sense. The highest understanding attained by a scientist is always an individual understanding. You can't say there's a collective understanding of 1,000 scientists. Each one has his individual understanding. And that is limited to what he can acquire in one short lifetime. So how much can you learn in one short lifetime? Let's say that for many millions of years, scientists accumulated knowledge, and it was all stored up in, let's say, some highly advanced computer memory, so that just by pushing buttons, you could read out any part of it as you desired. Well, still, you can only have access to a limited part of that knowledge, because you only have a limited time in which to study all that material. So still, that means for one scientist, there's an absolute limit onto what he can know. Unless, of course, he proposes to make himself immortal, which, of course, they would like to do. But we'll have to wait and see on that one. We'll see if anyone is remaining youthful for the next 50 years and consider that maybe he has a chance for immortality. But, of course, even that wouldn't prove anything. You could be youthful for the next 50 years and then get run over by a truck. So there's an absolute limit to what you can figure out using your mind and senses. So by that method, you have no hope. Let's face it. If you can prove anything scientifically, you can prove that you have no hope of really understanding everything scientifically. But if Krishna is really there, then you do have hope. So you can consider that. It's either nothing or maybe something. So why not consider the maybe something? What's the use of sticking stubbornly with nothing? Yeah? Oh.
You could argue that because, on the one hand, it's not like we have to reinvent the wheel every time we start over. There is a cumulative body of knowledge that we assimilate, just like we don't say the world is flat, and of course, this was thought to do in general. So that you may not be able to understand everything that is, like you were saying, it's scientific tendencies to learn more and more about less and less. But there are certain premises or modus operandi in the material world that people accept, just like they accept atoms or they accept whatever. So one could say that this is the scientific, this is the religious problems from keeping us like an ostrich with our head in the ground. We have made advancements. It's like I saw a recent film that was describing all the different, it was describing people trying to fly.
Yeah.
And it was the funniest thing in the world, seeing these things. People, it was amazing the way people tried to fly, you know, jumping off cliffs, off barns, little machines that wave their wings, and you couldn't believe the things. It was ludicrous. But the point of the film was that by that constant progression and trial and error, we do get in a 747 and fly to India. So if you had poo-pooed them in the beginning, we would consider you just not it. We would sort of be like Fred Flintstone.
Well, Fred Flintstone had pretty advanced technology. Look at all those trained dinosaurs that he had.
Anyway, there is a cumulative, we may not be able to understand everything, but why should we stay like the do-nothings, where there's no nothing? We have to make our progressive, we add our little bit, and gradually, life becomes better, and, we're pushing God, we're pushing out the parameters of knowledge.
Well, the point can be made that there's an...
My point being that there is a cumulative progression of knowledge.
Yeah, but how far can it accumulate? It's important to ask that. One has the idea, well, we can just go on to infinity. But how far can you accumulate it, this knowledge? For example, I can give the following analogy. Suppose I say that I'm going to jump over the boom, as one famous cow is said to have done. Well, I can practice to do it. I can engage in efforts to improve my ability. Now, the first day when I try, I may jump 3 feet in the air. And this isn't much. But by working at it, a few days later, I may be able to jump 4 feet in the air. And I can say, well, I've made progress. And then, working at it still more, I can come to the point of jumping 6 feet in the air. So I can say I've made more progress. And I don't know what the limits are, but what's the high jump record anyway? Anybody know? Trivia fans? Well, that's long jumps. I think we want high jumps in this case.
Well, when you say, taking that noise, when you say, well, look, we gave up on jumping, and we made a generally whatever it was, and we have done the moon. I got on my Twitter.
Yeah, but let the metaphor be understood in terms of the actual meaning of it. The point is that you may endeavor in a certain way, but that doesn't mean you can go unlimitedly. And I was pointing out a certain obvious limit. You see, in the case of jumping to the moon, there's an obvious limit. You can strengthen your legs to a certain point, but at a certain point, legs can't do anything more. I doubt you're going to jump more than 10 feet in the air ever, for example. So similarly, but you may say, well, with machines and so on, we can unlimitedly extend our ability. But as long as we remain human beings, we're limited by our mind and senses. So how much can you learn? You may say knowledge accumulates, but how much of it can you study? Now you may say, well, this isn't a practical problem. Actually, we haven't had any difficulty in extending our knowledge thus far. But that's not true. Actually, today, there's what is called the knowledge explosion, which bothers people quite a bit, because nobody can study all the different things that other people are coming up with. So nobody really knows what science is doing today. That's the point, that everyone is becoming narrowly specialized in learning more and more about less and less. It's not possible to learn all of the different things which people are studying. So one person can only have a few little bits and pieces of knowledge. So no one has yet seen how to get around that limitation unless you can build yourself a more powerful mind. Of course, someone can say, well, yes, in the future we'll build ourselves more powerful minds. But there's no real indication that you can do that. Anyway, if you build a more powerful mechanical mind, then that mind will inherit the future, but you won't. So, which of course, actually there's one newspaper reporter was interviewing a professor from MIT who was working on artificial intelligence. And he said, well, how can you, and the professor was saying that, well, soon we'll build computers that are 100 times more intelligent than a human being. And the future will lie with these computers. Maybe they'll keep us as pets. And so the reporter was saying, well, what about your own children? I mean, how can you work on machines that will replace human beings? And the scientist very nobly said that I feel myself obliged to aid the emergence of intelligence in whatever form it appears. So, but there is that limitation on what you can know. So, yeah?
There's some degree that there is a limitation on what you can know. How can you bring them to the point of convincing them that knowledge is available and actually want them? Otherwise, they may say, all right, we want to know. This is the best thing now, this is what we have, it's better than what we have, this is really well, it's not something that I wouldn't build with this, it's impossible to have to know that's the knowledge that we built. So relatively speaking, the better off out of the word. Why should I accept the Vedic one, even if there are scientific theories that are similar to what in the Vedic, there's no empirical proof for it.
Well, let's take the empirical method. Now, I gave an argument saying that, well, if there is God and all that, then you could hope to obtain knowledge by surrendering to God and so forth. That's also essentially the argument made by Pascal's wager. But let's say you don't accept that. All right. So let's use the empirical method. So in that case, let's investigate nature empirically. All right. Thus far, we've done things with gross matter and built various machines. So that's nice. But there are various frontiers of research which suggest new ways of enlarging our empirical view of things. So, for example, there's the dimension of the mind. There are the various psychic phenomena and so forth. The whole subject of parapsychology. So that can be discussed. Now later on we have an article here on consciousness. And we mention a couple of these things. Of course, one point about this magazine is that it's so brief that we hardly touch on these various points. But, for example, there's evidence, empirical evidence for reincarnation. Now, among hardline scientists, this is considered to be absolute rubbish. But all right, there's evidence for it. So how can you say it's rubbish? You're not being a real empiricist if you say that. A real empiricist has to look at all the data. If it's data that's coming in, then you have to look at it. How can you say that you're an empiricist if you don't? If you don't look at the data that's coming in, whatever it may be, then you're just being dogmatic. Now, actually, it's a fact that people, as a rule, tend to be dogmatic. It's natural. In a way, it's not even harmful if you've got the right dogmas. That's the advantage of having a civilization in which you really do have the absolute truth coming down. Because in a civilization like that, if people become dogmatic about this knowledge, then that's perfectly all right. Because they're becoming dogmatic about something that really is true anyway. Actually, the tendency to be dogmatic is there due to the fact that it's so hard to figure everything out using your senses. So therefore, people have a natural tendency just to believe something, regardless of what they see. So actually, the tendency of most human beings is that they believe a given thing. And if they see something that contradicts it, they think there must be something wrong with what I'm seeing. Anyway, I don't believe it. And they go on believing what they believed before. Most people are like that most of the time. So that's known as being dogmatic. So the scientists also tend to be that way. Of course, they accuse the religionists of being dogmatic. And it's true that religions have come up with some interesting dogmas. It's been argued that the world was created in 4004 BC, and that if in a short life of maybe 70 years or so, you don't surrender to Jesus, then you'll burn in hell for eternity, and other things which have got certain drawbacks. And so therefore, dogmatic religion has acquired a very bad name. Other people have acquired the idea that if somebody doesn't accept the dogmas of the current religion, then we should put him on something known as a rack, in which we pull him out, stretch him out with ropes until all his joints burst open. And meanwhile, we should light a fire under his back and stick sharp spikes under his fingernails. And then, finally, if he accepts our dogmas, then we should take him out and burn him at the stake. So these kinds of things gave religion a bad name, and the scientists are carrying on the noble tradition of opposing religious dogma in order to save people from this kind of thing. So they will say dogma is very bad, but unfortunately, like other people, scientists tend to be dogmatic. So the tendency is that they will accept a certain viewpoint. So the physicists, for example, have a certain theoretical picture of what is possible in nature. And they view everything as made up of atoms, electromagnetic fields, subatomic particles, and various things like this. So if you tell them, well, here we have evidence that a person is remembering a previous existence, they will say, well, as far as our picture of things is concerned, that's simply not possible. Physically, there's no way that could happen. So therefore, it doesn't happen. So therefore, if somebody reports this, there's a mistake somewhere. Maybe somebody's making up the story, or something like that. But the fact is, there is evidence like this. So you can delve into it and see what the evidence is. Now, naturally, if you do that, since you're using the empirical method, you're going to run into problems. But if you're going to use the empirical method, you have to expect that. It is imperfect. You can never really be sure. There are always other ways of looking at the evidence and so forth. But that's the way it works with science. So if you say we've made all this great progress using that imperfect method, then why not use it here? Why say at this point, well, it's imperfect, therefore we won't accept the conclusions? Because you were just arguing a few minutes ago that using these imperfect methods we've made such great progress, so why shouldn't we use these methods? So, using the same imperfect empirical methods, you can, for example, find that there's evidence for reincarnation. But if there's reincarnation, what does that mean? That means that some kind of organized entity with mental powers, with memory, with emotions and so forth, which is completely invisible, is leaving one body that dies and going somehow to another body which is being born, or maybe going into that body before it's born. Who knows exactly how it works. But somehow that has to be happening. And that's completely invisible. So that immediately means there's an invisible world. And it's inhabited with sentient beings. So immediately you accept one of the basic tenets of religion. Because all religions basically have said there's an invisible world, it's inhabited with beings who have different powers and so forth. So empiricism leads you to that conclusion. And then in this magazine we also indicated these out-of-body experiences. For example, here's a picture of a fellow, a sort of ghost-like being hovering over an operating table. So the point is that people with medical crises in which they go into a coma have in many cases awakened from the coma and reported that during the time that they were supposedly out of commission physically, they were experiencing what was going on around them from a different perspective. For example, this shows a person who's had a heart attack being resuscitated by the electroshock method, in which they put two what they call paddles on the person's chest and put an electric shock through them. And this jolts the heart back into operation. So during that time, the heart is not beating, which means no blood is going to the brain. And if that happens, the person passes out almost immediately. You maybe know what happens sometimes if you get up very quickly and you feel a little faint. The explanation is, well, the blood circulation to the brain isn't working quite right. So just for a moment, if the blood circulation is cut off, you begin to feel faint. So if the heart completely stops, you black out completely. At least this is the understanding that the doctors have of what happens. And if it's stopped for more than a few minutes, then there's irreversible brain damage. So the idea is that this person's heart is stopped. His brain supposedly doesn't work according to medical science. This is empiricism, of course. You can say, well, maybe we don't understand things properly, but still, let's accept the progress that we've made in medicine. We are not against progress, right? So, accepting this progress, we accept this understanding. Well then, the person wakes up from the experience later on and says, well, doctor, while I was out, I saw what you were doing because I was floating above the operating table in a subtle form. And I heard everything you said. You said this and this, and you cracked a certain joke about my protruding abdomen, which I definitely dislike very strongly. And furthermore, you did this, this, and this, and it turns out that it's right. So how did that happen? So there's empirical evidence for the existence of the subtle body. So, if a person is actually an empiricist, then he can consider these things. Now, of course, the road of empirical investigation is a very long road. You can't just instantaneously come to final conclusions. But that's the way it is with empiricism. But you can consider this. And it can be argued that if you consider empirical evidence, then the Vedic picture of things is not perhaps so bad. But that's a very long story, of course.